Okay, grade 12s. Hope you're doing well. So today we're talking about the derivative at a point, and this is practically how you're going to apply it in an exam or a test. This is practically how it will look like. Remember, doing it from first principles, you only do that when asked to. It takes far too long to try and do that every time with every calculation. You only do that when asked, let's say by definition or from first principles. All of the other times you use the shortcut methods, the rules for differentiation. Okay, so let's talk through a few examples. I'm working from exercise 7, number 1. Determine the derivative of each of the following functions at the given points. And then they give you 3 coordinate points. The function looks like this. Fx equals negative x squared plus 2x plus 8. Okay, now they give us various coordinates. Now we are only interested in the in the x coordinate, because if you have the x coordinate you can determine the gradient at that point. Okay, but first step, before you even start by substituting and anything like that, the first thing you do is you calculate the derivative. Remember, the derivative is an expression for the gradient at any point. Now we use our rule, so the 2 goes to the front and it's being multiplied with negative 1, so it becomes negative 2, and the 2 becomes a 1 there, so it becomes x plus 2, because the x, 1 minus 1 is 0, that becomes a 1, and the 8 falls away. So this is your derivative. Now you've set yourself up to solve the rest of it. So now they ask you at a, where this is the coordinates. Remember, you want the derivative at those points. That means the gradient at that point, right? So all you're going to do now is you are going to calculate the derivative where x is negative 3. So negative 2 times negative 3 plus 2, and you will see this becomes a plus 6 plus 2 is equal to 8. So at that point, the gradient is equal to 8. Can you see we did not use the negative 7 at all, because that was not, it wasn't needed. Okay, and you'll see that for B as well. They give us the following point. They say 1 and the y value where x is equal to 1. Can you see it's just a different way of writing it? It's exactly the same thing. So now all we are going to do is we are going to calculate the derivative where x is equal to 1. So it's negative 2 times 1 plus 2. So at that point it's equal to 0. Can you see that? If the gradient is equal to 0, that means it is a turning point. Remember that. Okay, then the last one is a 0. Okay, in this case we do not have the x coordinate, but we do have the y coordinate. So now we first need to get the x coordinate. So remember, our equation is fx equals minus x squared plus 2x plus 8. This is our actual equation. In order for us to get to a, we have to substitute in both of these values. So in y's place we put 0, and then in x's place we put a. And now we just simplify. Okay, I always try to work with positive, like the square, to have it as a positive. So I'm going to multiply the negative 1 all the way through, and now we simplify. So that's a negative and a negative, so it will be minus 4a plus 2. Therefore a equals 4, or a equals negative 2. Okay, now we've got 2 places where we have to calculate the gradient, and for this one we just say now the derivative where x is equal to 4. Okay, and for this one the derivative where x is equal to negative 2. Now just calculate. This becomes a negative 8 plus 2 is negative 6. Right over here, this becomes a plus 4 plus 2 is a positive 6. Okay, so just to interpret this, where y is equal to 0, that means the what? The x-intercept, right? Where y is equal to 0, our x coordinates is negative 2 and 4, and at those points we have a positive gradient of 6 and a negative gradient of 2 at those points. So if you want to have a little graph like that, it does that, right? And that's 8, and this is negative 4 and 2. So at that point the gradient is equal to 6, and at that point the gradient is equal to negative 4. And remember, a tangent's gradient is always the same as the graph at the point where it touches it. Okay, so keep that in mind. I just want to point this out with question B, where x was equal to 1, the gradient was 0. Okay, so that is our turning point. So right over here, x is equal to 1, and that is our turning point right there. So can you just be on the lookout for information like that in your answering of the question. So next question, question number 2 for exercise 7. So over here, same questions, same thing, just different function. So they give us this expression, they want the derivative at various points. Remember, the very first step you need to take is to calculate the derivative. In order to do that, rewrite your equation in a form where you can use the differentiation rules. Okay. So from here, we can calculate the derivative as negative 4 x to the power of negative 2. Now we are not going to use it in that format. We are going to use it in this form. Okay, so you write it down like that. So this is our derivative and this is our function. Okay, so we are going to use this all the way through. So for A, they give us the coordinates negative 3 and negative 4 over 3. Remember, we are only interested in the x value when we're calculating the gradient, okay, with the derivative. So now we just put negative 3 in here. And you can see there it would become a positive 9, so this is negative 4 over 9. Okay, so for number B, it was 2, and the y value when x is substituted in is 2. So again, we don't need that value for this calculation. So we just calculate the derivative. You can see it's a negative 1. For C, they told us it's b and 1. So in this case, we have to use the y value with the actual function's expression, okay, so that we can get the x value. So we first need to determine b. Okay, so gx is equal to 4 over x. So now we substitute b and 1 in, so this is 1 and x is b. So that means b is equal to 4. And now we can calculate the derivative where x is equal to 4. Please note the notation that I use. Okay? Negative 4 over 4 squared becomes a 16, so it's minus 1 over 4. Okay, so this is the gradient of the function where x is equal to 4. Just a quick glance at how this graph looks like. It's a positive hyperbola graph, so it looks like that. Okay, and we initially calculated the gradient where x is negative 3. So it's probably somewhere here. you can see it has a slightly negative gradient. Okay. Then secondly, we calculated it where x is equal to 2, somewhere there, and you can see it also has a negative gradient. Everywhere on this graph it will have a negative gradient, right? And then for C, where x is equal to 4, it has a slightly negative gradient somewhere over there. You can see how this works out perfectly fine. Okay, then the last one for this video, and that's number 3. Okay, so let's look at number 3. This is a cubic function, and a cubic function is very interesting, but let me, just for interest sake and for your sake, let me just draw the two basic shapes of a cubic function. It can look like this, meaning it increases, decreases, increases, or decrease, increase, decrease, meaning a positive gradient, 0 at the turning point, which is also called the stationary point. Then the gradient is negative, then 0, and then positive, or negative, 0, positive, 0, negative. You also get functions that looks like this. This is also a cubic function. This is a special case, it's x to the power of 3. Remember, it can, let's just say a, it can be any number there, as long as it's positive. And then we have one looking like this. This is negative x to the power of 3. It looks like that as well. So, but we are not focusing on these now. We'll do them in a few days. So this will just, you will notice this when we do our calculation. Okay. First step is, as always, get the derivative. So it's 3x squared minus 2x negative 16. Okay. Now we're ready to do our calculations. So for A, they told us negative 328. Now we just substitute. Okay. So it's negative 3. So it's 3, negative 3 squared minus 2 times negative 3, negative 16. So here goes, 9 times 3 is 27, minus 6, plus 6 minus 16. So it is 17. Okay, now let's look at B. With B, they told us it's 2, and the y value wherever x is equal to 2. Get the derivative for x equals to 2. So it's 3, negative 2 squared minus 2 minus 2 minus 16. Okay, so this becomes a positive 4. 4 times 3 is 12, plus 4 minus 16 equals to 0. Interesting. So that's the turning point. Okay, and then for C, 1, and the y value wherever x is equal to 1. So now we just calculate this at 1, and then you will see this is a 3 minus 2 minus 16. So it's 1 minus 6 is negative 15. Okay, so we've got 3 coordinates here. So let's look at what we've calculated. Okay, so just to illustrate, we have the function, and where x is negative 2, we have a turning point. Okay, we'll see now which way it goes, right? Where x is equal to negative 3, we have a positive gradient. In other words, the graph is going upwards, so it looks like this. And then where x is equal to 1, we have a negative gradient, looking like that. Okay, and it also makes sense if you look at the graph. Its y-intercept is positive 16, and this graph will most probably continue to look like that. But this just gives you an idea of where we are and how this graph looks like. Okay, hope this makes sense.